Excellent. Well, thanks everyone again for being here. So a bit different from what has been the 3 previous presentations. So where we have seen papers and published work. So the itinerant project is starting, so it's work in progress. So what you're gonna see are preliminary outcomes. But nonetheless, so there are, I think, some interesting takeaway messages and things that we wanna get started thinking and discussing. So the itinerant project, so itinerant stands for Inequalities in Experience Urban Function. So that's essentially the gist of the project, and I'm gonna unpack a bit that during the presentation. So the itinerant project is funded by the Alan Turing Institute, so through the Urban Analytics program, and that is what is bringing us together today here. So an overview of the project. So I guess here I don't have to convince you that understanding cities is very important. So I think Esteban provided a really nice introduction to why we need to understand cities and why mobility data are important. So I'm probably not going to spend much time on that. So Esteban also mentioned about what are the biggest challenges that we see in urban spaces. So particularly, so Esteban spent quite a bit of time talking us through socioeconomic segregation. And so on this project, we focus on an issue that is closely related to socioeconomic segregation, which is spatial inequality or socioeconomic inequality, particularly in the context of COVID-19. So we have seen that socioeconomic inequalities have been exacerbated by the pandemic. And we're also here so thinking on making contributions and contextualizing the projects in the context of the leveling up agenda and the equal recovery agendas. So both related to inequalities and COVID-19. And here we want to take that opportunity and the advantage of some of the, so we want to leverage on some of the advantages that Esteban was referring to, and using mobile phone data to get some early impressions of the impacts and hopefully what is going to be the recovery from COVID-19 in cities. Why? So I guess the question is, why at the Alan Turing Institute? So what it is just a great place where we have a pool of talent on mobility data, and therefore we can organize and have this workshop as we're having today, and have all these great minds on mobility with lots of experience. And also we are linking and framing this within the framework of Turing, because there are quite a lot of interesting existing projects that we are planning to use and we are using, and that is going to enrich the outcome of the project. So in particular, here I'm talking about the Urban Grammar, which is led by Danny, who is part of the team, but also Spencer. So the project is led by Nick Lomax at the University of Leeds. So I'm gonna try to unpack that a bit later. So what is the aim of the project? Well, the aim is to understand socioeconomic inequalities in access to urban function through mobility data. To do that, so we are thinking of 3 different, if you wish, work packages. So the key first idea is to develop a functional classification of urban spaces. So what places offers, and then looking at how we can understand and link mobility data with the way or with the functions that these places offers with that classification that we're planning to create. And then it's going to be about unpicking socioeconomic inequalities across different population subgroups. And here is where we want to be addressing some of the biases that we have been discussing today, and that has been exposed during the earlier presentations. So just to give you a bit of sense of what the project is going to do. So for the urban classification, we're expecting to build on some of the work that Danny and Martin have done in the context of the Urban Grammar project. So the first key idea here is to develop a functional classification, as I mentioned earlier. So the key point then is about identifying places that got a similar functional profile. And for that, we're gonna use something called tessellation cells. So that tessellation cells are enclosed areas by barriers such as roads, fields, and anchored by buildings. And that addresses some of the issues about spatial aggregation. So building from that basic unit of analysis, we want to first classify those areas based on functional data. So we, in a sense, we want to infer functional, so the function of an area from different data sources. And here, different data sources, I mean, population composition, satellite land use types, distance to different point of interest, and a number of local amenities. So we are gonna embed all of the different layers of these different dimensions of the urban area and combine them using some cluster algorithm. And then the idea is to identify special signatures. So what are the function of the different spatial areas? And then in this particular context, and in the context of the presentation, I'm gonna focus a bit on what is gonna be presented later in terms of preliminary outcomes. So after we have designed that functional classification, what we have done, because we've been working with Facebook data to start with, as we wait for access to more detailed and granular mobile phone data. So the data from Facebook, so they are available on tiles. So what we have done, so after we classify and develop this functional classification, we aggregated and assigned each of the tiles that we see within the Facebook data to one of these functional areas. And then we have created on the top of that a different cluster algorithm to identify 4 broad areas that sort of encapsulate a bit the functional form, but in the broader sense. So we identify 4 different areas: countryside, mixed use, countryside, residential areas with high commuting, and highly served mixed use areas. So then the second idea is to start understanding the mobility patterns. And essentially here, what we want to do first, as a first layer of analysis, is to determine spatial and temporal variations in mobility intensity across functional areas. And we want to also do this for different socioeconomic groups, so to better understand how people access and use space and the functional space. So then we are pretend to use 2 different sources of data. So one is data from Facebook. So what we get is aggregate data or in destination matrices at the tile level, 6 kilometers. And we also gonna have access to opt-in application data from Hack through the CDRC. So the key idea will be first to look at different dimensions of mobility, particularly looking at migration intensity. So how often people move, how often people move within a certain place, how often people move between different places, and then redistribution. So looking at out, in mobility, but also net mobility. So ins versus out. And then we expect to use these different metrics of mobility to start understanding the spatial and temporal variations across different socioeconomic classes. So it's going to be an analysis over space, over time, across different socioeconomic groups to look at the composition. So now over to Alessia.
Yes, thanks, Francisco. So As already Francisco mentioned, we're at a very early stage, but we thought it could be interesting to just show a few preliminary results that we had working with Facebook data. Francisco, if you can please go to the next slide. Thank you. So we have been working with this longitudinal data set that Facebook released within the framework of Data for Good. This is origin destination movements at different points in time. So we have 3 time intervals. Midnight, 8 a.m. and 4 p.m. And the way movements are captured is to look at the people that moved the 8 hours before this time point referent that started the movement in the 8 hours before and ended in the places where they went the 8 hours after this point in time. What we wanted, and again, the spatial, just to Francisco already mentioned, the spatial granularity of this data is grids of approximately 6 kilometers times 6 kilometers. We started analyzing this data by looking at the extent to which they are able to capture variation in movement. So we picked 2 periods of time when there have been quite significant changes in the way we move. So we picked the first month after the first lockdown from 23rd of March 2020, and the first month after what in the UK has been called also the Freedom Day, so basically when all restrictions were lifted. And on these 2 time period, we calculated a number of mobility metrics. But before then moving to the metrics themselves, I just wanted to show, and if Francisco, if you can, thank you. So I just wanted to show you another data set that helps understand a bit better the movement data set. So Facebook, along with the movements data set, also provide population, the Facebook population data. So for each point in time, it gives the number of people that, the number of Facebook users that have given access to their location history, which is the basis from which then they can derive movements. And so we've taken the average Facebook population across the UK, and we compared that with the resident population. On average, Facebook population coverage.
Alessia, I think we're missing you.
Can you hear me? Hello?
Now, yes. Yeah,
oh,
but we
I'm sorry.
Okay,
wait a bit. So yeah, I was just mentioning the coverage of the population. So this map shows the proportion of Facebook users that so the proportion of resident population that correspond to the Facebook user population. On average, this is about 30%. Many places, particularly the more populated places, have a coverage of less than 10%. But there are some places, so those yellow dots that you can see, that tend to have more than 30% coverage, but also quite higher than that, even more than the population. Some of them are places that tend to have some natural beauty, and so they tend to be attractive for people that don't live there, but they go there. So rather than capturing resident population there, well, this showed that in a way that this is able to capture more the number of people that are there at a certain time, which is what we were more interested about. So if you can go to the next slide, Francisco, please. Thanks. So very quickly on the, so what we do was to calculate mobility metrics. So we calculated outflows, inflows, and intramobility, where intramobility means localized movement. So movements that happen in the same cell. For the first month after the lockdown, so full lockdown period, and the month after the restriction were lifted. And then we simply take the difference in the number of trips to see what we could capture with this data. And so what we saw is that, while overall mobility has increased as expected, outflows and inflows tend to have increased, particularly in major cities that are quite easily visible on these maps. While intramobility has a relatively more interesting pattern, so that if you see, well, yellow areas are those where the number of trips has increased, while when you go towards the bluish violet areas, we have a decrease comparing to the lockdown. The areas where we've seen this decrease tend to be mostly around major cities. So, and that means that there were more localized movement around in those areas than when the restrictions were lifted. So this might suggest the influence of maybe a return to normal, let's say, in the working pattern. So going more towards the workplaces might have somehow meant less, let's say, vitality, although during the lockdown, nobody was particularly vital, but that there was in those places during the lockdown. So if you can go to the last slide for this part, Francisco. So we also wanted to try and integrate mobility, these mobility metrics with the functional classification. Francisco already mentioned how we did how this is classified, and so we run a model that looks at the relationship, actually two models, one for the first for the lockdown period and one after the restriction were lifted, to look at the relationship between the proportion of movements across origin and destination and their specific functional classification pair. So from the plot that you, from the tile map that you have on the right side, top right, you can see the global coefficients for each functional class pair that we derived from, actually, that we derived this global coefficient for each of the model, and then we picked the difference to look at how more likely could be that people moved from a certain function to another function after the restriction were lifted. So there we can see that it tends to be relatively skewed towards the highly served and mixed use area. So basically here, what we again tend to see might be still related to the changes in commuting patterns. So residential areas versus highly served mixed use areas have had a quite significant increase. So I now leave it to Francisco again to go through the final point, because again, these were very, very preliminary results, and we still want to do lots of things. So over to you.
Yeah, so I guess following from that, so some of the things that we're expecting to do over the next few months is, first is looking into deliver the functional classification of areas that I was describing earlier. So we're still iterating, trying different segmentations and looking at what seems more reasonable to understand space and their function, but also in which way that help us to understand a bit better why and from where people moved from and to. So we're expecting to release an open data product, so early 2022. So then keep posted on that. So, and then the second bit is looking into a bit more in detail at the mobility patterns. So now we have access to application data, so we can look at individual digital traces. And so we're looking now into developing our analysis on hack data. So an understanding a bit more on how individuals use space and which functions they tend to move from and to within the UK. And then finally, what we are expecting to do is also trying to integrate and achieve a bit more granularity in the way how we are planning to analyze inequality in the experience of function. So we're planning to use and try to get population estimates from the Spencer project, so the scientific population estimation and the scenario projection. So the key idea there is because Spencer is providing a population estimate, a very high resolution, so a household level. So we believe that there could be potentially a lot of benefits from using data at the individual level in terms of mobility and using population, dynamic population data to describe places. So, and then the idea is to combine those different data sets and refine our models to start looking at differences between different socioeconomic groups in the UK. So, and I guess, so here, one of the things that we've been thinking, and I think some of these approaches have been mentioned, is so various challenges that we are anticipating, and that probably could be, so rather than getting only questions, so I would like to pose some questions as well to the audience. And so Esteban mentioned a few of these approaches, and it would be good if he can share more a bit about those. But essentially, so I think there are some key challenges here about working with mobility data in particular. So one of the things is selection biases, right? So we have a population from which we get data, we draw data, which is different from the general population. So there is a bias there on who uses mobile phone, but then there is also a greater bias in terms of who uses smartphones, and then who uses certain applications. And because usually when we get the data, we normally don't know what applications they are from, right? So then there may be gender biases, there may be age biases, and we don't know. So I would like to know a bit on standard practices, because I don't think there are quite established and refined, well-developed standard practices on how we address these selection biases. So similarly, when we think about standardized frameworks for managing privacy and animation, so what are the standard practices that people use, as well as scalability issues. So one of the things is when you have and are working with 7+ million observations. So the traditional statistical models that we used to apply, so they tend to fail on converging. So then there are different ways on how you need to slide the data and model the data in different ways. So we would like to know about approaches on scalability, as well as sparsity, regularity of the individual trajectories. Sometimes you get trajectories that are that collect quite dense set of points regarding time and space. And in other cases, you get 2 or 3 time points for an individual. So how do you deal with those sparsity and irregularities in trajectories? And lately, so about missing records, particularly when we get the aggregate data. So normally you get these NAs of missing records. So it's about the treatment of those. Does it mean So 0 flows, 0 trips, or does it mean missing records, or just that there isn't records, or there might have been flows of users, but we don't have observations on those. So I guess a few points for discussion there. And I hope to have more to show you next time. Thank you.
Thanks, Alessia and Francisco. And I guess there is time for one question, and that is, well, basically, what do you expect to be different in the results and in the analysis with more granular data that goes, it looks at a more local level than the Facebook grids? And Francisco talked about the challenges, and I mean, maybe if you can touch upon the opportunities.
Anyone wants to go from the team, or would you like me to go first? Okay. So I guess there are. I mean, I think Esteban's presentation has highlighted quite a lot of the things that you can do when you have this individual level data, and it's understanding different layers of mobility and the different layers of cities, right? So understanding. So starting by the individual, so how people tend to experience and use a space, and how those patterns of spatial segregation get formed. So it's actually understanding the temporal dynamics of the process, right? So when you have aggregate data, so you kind of get this static picture, so of when move happen between an origin and a destination at a given point in time. Looking at individual trajectories, you can start understanding visitations of places, durations of stays, and also the attributes of particular places. Because with aggregate data, you only get an idea of the actual aggregate of the place, right? So with individual level data, so you can start looking at point of interest, which probably is one of the things that you want to know. So you want to know what sort of places people tend to visit, and probably then why. So Alessia, you want to elaborate on that?
Just a quick one, because we are also running out of time. Oh. And I shouldn't be the one to make it happen. No, but just to say, I think also from a spatial perspective is the nature of the spatial phenomenon that you can capture that varies. So in this, with the Facebook data, it seems we are able to capture movements more at the regional level, or when it's urban level is not less than a combined authority, I would say, but with more granular data, we would be able to capture a relationship between places at more the urban scale. And now I leave it to Danny to introduce the new speaker, the next speaker, sorry.